All right, so we are solving logarithmic equations. There are two situations that happen. So this is one of them where you have a log on both sides. So we have a log equal to a log. Okay, and I've got the steps here for you. I would definitely copy these down so you have a nice little checklist. So the first thing we got to do is we got to combine or condense things together, which for this is going to mean the 3 here. Okay, so let me zoom in. My handwriting shows up a little nicer that way. And we're going to take this 3 and we're going to use properties of exponents to bring that up as an exponent. And we're just going to rewrite this. So I've got log base 2 of 8x equals log base 2 of x to the 3rd power. Okay, now since it's just a log equal to a log, I can set my ofs equal to each other. So remember that reading logarithms correctly is going to be really important because I'm going to keep referring to things as the base and the of and the equals. So my ofs here are 8x and x to the 3rd. Now, it's not that the logarithms actually cancel out. That is not what's happening. It's that one-to-one property. You can still think of it that way in your head, but that's not what's happening here. We're dropping the logs just like we dropped when we had the rational functions and all of the denominators were the same. It's not that they went away because they still caused domain restrictions, but we can effectively ignore them and just focus on the pieces inside, because the pieces inside have to be the same if you have log base 2 on both sides. Okay? And then from here, our next step is just to simplify and solve, right? We love that solving for x goodness here. Now this is a quadratic. They won't always be quadratics, but we figured we would do some examples where it was a little bit more steps so you had some good worked out ones. So because I have x to the 3rd power, I need to set one side equal to 0, and I'm going to just try to keep that x to the higher power positive. So I'm going to move my 8x to the other side. And then from here, I'm going to factor and solve this. So I can take out a GCF of x, leaving me with x squared minus 8. Man, if that was x squared minus 9, ooh, we could make it into a nice conjugate. I mean, technically you still can with these, but I'll show you the other way to look at it as well. So from this piece, we're going to split and use the zero product property, and we're going to set x equal to 0, which becomes one of our possible answers, and we're going to set x squared minus 8 equal to 0 and solve it. So I'm going to add 8 to both sides, and then I'm going to have x squared equals 8, and when I square root this x squared, remember the square and the square root will knock each other out, but because it's a 2, I should have 2 answers, so the other side becomes plus or minus square root of 8. And if you did simplify this down, it would be plus or minus 2 root 2 as another possible answer. Okay, so let's zoom out a little bit here and let's look at this, because the last step here is checking that your of is greater than 0. And the explanation of that is in the other video for you. Okay, so make sure you kind of take a look at that piece if you want to know why is it that that happens. So I'm going to show you our values for x, and I'm going to list all of them out. I have 0, I have 2 root 2, and I have negative 2 root 2. So we have a domain restriction situation going on here, and we have to make sure that whatever we plug into here is going to be greater than 0. It cannot be a negative, it cannot be 0. It's got to be a positive number. So the easiest one to check, and what I'm going to do here is I'm going to talk through a couple, and then I'm going to pause the video and just make the rest of them pop up so that you don't have to sit through it. The easiest one to check, and you have to check all of them just in case, is where I just have x, okay? I have x has to be greater than 0 because this guy in itself is just an x. So I'm also going to check my 8x here and see if 8x is greater than 0 by substituting these values in and seeing if they all work. Sometimes they all work, sometimes only some of them work, sometimes none of them work. So you just got to kind of play around with it. So this would be 8 times 0, and checking that that's greater than 0. Well, that turns into 0. So that actually does not work, which means that this does not work as an answer. And even if you substituted it into this one, and sometimes it'll work for one and not for the other, that does not work as a possibility. Okay? So I'm going to work out the other two as well. If you want to maybe skip a little bit through so you can go through it a little faster, feel free. But I have 8x has to be greater than 0. So if I do 8 times that 2 root 2, well, it's a positive times a positive, which means it's going to be greater than 0. So this one works in that situation. And then I have to have x greater than 0, which again is just what the of was from my original equation. That inside that parentheses was just an x. And 2 root 2 is absolutely greater than 0. Oh, okay, I guess that's not going to work. I was going to try and color code that for you. So that guy works for both situations. And then you just want to do the same thing with the last problem here, with the last possible solution. So I started off, my two ofs from my original equation were 8x and x. Okay, and I'm going to substitute in and see if this last one works out. So I'm going to substitute in negative 2 root 2. Well, positive times a negative is going to be a negative number, and then it of itself is a negative number. So this one does not work either. So we actually only have one solution of the 3 that we solved for that actually works. So the only answer that works here is 2 root 2. Okay? That takes more to explain than it's going to take you to actually check in a calculator. Okay? But I want to do at least fully go through and explain one of them to you. So let's look at this next problem. The first step is to combine or condense so that we have one logarithm on each side of the equation. And since the left-hand side has a log plus a log, I can use those rules, my log properties, to combine them and have x plus 32 times x. That was me combining these two pieces together because this and this, since it's addition, will become multiplication. And that equals log base 2 of 68. Okay? Now, since we have just a log base 2 equals a log base 2, that one-to-one property tells us that whatever's inside of here, whatever my ofs are, must also be equal to each other. So I have this guy equals this guy, and then I can go through and solve. I can distribute, and then since again I have an x squared in this case, and they won't always have x squareds, but since I have an x squared in this case, I'm going to set it equal to 0 so that I can then factor it and solve it, telling me that I should have 2 possible answers that I will need to check. So I've got my factoring all set up. I need numbers that are going to add up to 32 and multiply to negative 68, which for us is going to be positive 34 and negative 2. And if I set those equal to 0, I'm going to end up finding out that x equals negative 34 and positive 2. And then for the sake of the video, I'm going to pause here to check solutions, but I'm going to have it, so it's basically that, well, the work for it is just going to appear, okay? All right, so I did my little check here. So I went and I looked at my ofs. I had x plus 32 inside of an of, so I checked x plus 32 being greater than 0 for 34 and for 2. And the of in the second piece was x, so I checked that x was greater than 0 again for both pieces here. Since this did not have a variable in it, I did not have to check that one. But if we started off here with this being a negative 68, right away you would just cross it off and say it doesn't work, okay? So, very important that the of has to be greater than 0. So as we see in this one, I end up with a negative 2 here and a negative 34 here, so that negative 34 does not work as a solution, but it works out in these two problems. So our answer here is x equals 2. Okay, and then at the bottom, this is blank for you, so make sure you copy down two very important things. Your log bases must be the same to set those ofs equal to each other. So that means up here, if this was log base 6 and this was log base 2, we could not set these equal to each other. They have to be the same. So that's important. And then again, I'm just going to keep reiterating, you've got to check for extraneous solutions because it's all about it being a function. And the other video will have an explanation of that at the end of it. Okay?